Welcome to the introduction to probability. So in this chapter, we're going to look at the fundamental concepts of probability, how to measure uncertainty using statistical analysis of probability, and also using what is called Bayes' theorem. So to start with, there are different types of probability. So I'll explain starting with what I'll call a glossary of terms that you need to know. We're going to discuss what an experiment is, what an outcome, the sample space, and an event is. So in probability, we'll be using terms like an experiment, which is simply the process of measuring or observing an activity for the purpose of collecting data. Dealing with a sample space, we're simply looking at the possible outcomes that experiment may have. An event is simply the subset of a sample space. So if you're looking at GBS 541 students and I pick 10 of them, those ones are just what we call events of students taking MTP, events of students taking QM out of the whole MBA general class. So in short, an event is simply a subset of the sample space. So to define classical probability, I'm going to use an example. So this example simply states the probability of A is simply the number of all possible outcomes in which event A occurs divided by the number of outcomes in a sample space. So if I'm dealing with fruits, for instance, and I have 7 apples, and I also have 3 bananas. So my sample space of fruits is 10. So total number of fruits, we have 10. So now to find the probability of the event A, it is simply the number of outcomes of the apples, so probability of A over the total sample space of the fruits. So what is the probability of picking an apple? It is simply 7 out of 10. What's the probability of picking a banana? Is the number of bananas over the sample of all the events of which are the fruits. So this is 3 over 10. So I'm trying to be as basic as I can so that I don't confuse you. Are we together so far in determining the sample space?
Yes.
All right. So we now go to understanding what we call subjective probability. And when dealing with subjective probability, it is simply a term used when classical and empirical probabilities are not available. So under such circumstances, we're going to rely on experience and intuition. So subjective probability, we use it when we want to answer a question. For instance, what is the probability that a company like Lafarge will make a profit next year? So we're going to base it on the performance in the past years. So this is just basic probability. So now I'll quickly take you to what is called Bayes' theorem. So when we're looking at Bayes' theorem, we're looking at a theorem that was developed by a statistician called Baye'S. So he brought up a concept which is called conditional probability. Now I'll summarize all this jargon into 3 key principles. Number 1, that we have a rule of total probability, which simply says that probability of A or probability of B is simply probability of A times B given A, given events starting from J is equal to 1 up to K. Now, what this simply means is that if we have events as follows, Bayes' theorem is simply a rule or a pattern. If you have probability of A given B.
One moment. I am serious. And don't.
So Bayes' theorem simply says probability of A intersection B must be divided by the probability of B. Now expanding this simply as follows. This on top is simply the probability of what? A times the probability of B given A. And the bottom part is simply the summation of probability of what? From J is equal to 1 up to K. A times probability of B given A. Now the key thing that I need you to master is simply the pattern that probability gives you. If we have B given A, this is simply the probability of B intersection A. Then we drop down our A down here. So you notice how the pattern is interesting, that this guy drops here. Now this also gives birth to a shortcut of the intersection, which is very important. So probability of A intersection B, when you cross multiply here, we're simply going to have probability of B given A, and you multiply it by probability of A. So this is coming from B given A, you multiply by this A, which is down there. So this gives us this probability. If we're going to expand this one here also, it will give us probability of A intersection B will simply be here. This is 1 times A intersection B. We have A intersection B. Then A given B multiplied by B. Probability of A given B, you multiply this one by what? The probability of B. So intersection is simply the commonality. So A intersects B at that point. So this is called A given A intersection B. So this is probability of B. That is simply A intersection B. For these events that are not common, it means they are independent events, they're disjoint events. So A intersection B is an empty set. So this is called a mutually exclusive event. You can also put an empty set here. Or this is 0. There's nothing common between A and B. A union B is when we are adding. So probability of A union B is simply probability of A plus probability of B minus A intersection of A and B. So these are the basic rules that you need to understand when you're dealing with our probabilities. So probability is interesting, especially that you can use Bayes' theorem to explain conditions. So if, for instance, you have the probability of A as 0.4, it's probability of B, meaning probability of A maybe 0.6. Each mouth here should give you a total probability of 1. Then maybe this is a probability of a defective coming from B. This is 0.1. And here we have a defective coming from A. This is 0.6. We use a neutral number 0.7. So like I said, each mouth must total up to 100. So this one therefore will be the probability of D complement coming from where? From B. So this one will give us 0.9. This is probability of D complement coming from where? A. 0.3. Now remember, I was trying to give you a very short way of understanding how to come up with an intersection. So if I'm going to multiply the probability of B times the probability of D coming from B, as long as these ones here, the base is a multiplicand, this will become an intersection. This is D intersection what? B. We know that intersection is the same as multiplying. Union the same as adding. So probability of B times D given B, when you multiply them, we're going to get the intersection of what? D intersection B. So this one times that one, we get 0.04. If I multiply probability of A,
Sorry, may I please just repeat that? We don't go back.
okay. So coming from Bayes' theorem, you need to know manipulations. So these manipulations are going to be very helpful for you to understand quickly grasping probabilities. So what do I multiply X given Y to get an intersection? The Y itself, it's cardinal. So X given Y times the probability of the Y, I'm going to get what? The intersection of X intersection Y. So you now tell me, if I have probability of M, what do I multiply it? M, N given what? M. This is the same as that. So the total, if I multiply it, to be the probability of what? N intersection M. All right. So tell me, what am I going to multiply A by if I'm dealing with two letters to get the intersection of A intersection B? I multiply it by B given A or A given B. In the first place, for this to be an intersection, this A must go down here. Then the other letter, which is B, is one that comes there. That's how this pattern suffices. So A is supposed to be multiplied by B given A to get the intersection. Is that clear?
Yes.
Then when we're adding intersections, you get a common letter throughout. So if I'm adding all these intersections, the common letter is what? X. So the total probability is going to be the probability of X, since we have the common letter throughout. Now tell me, if I'm going to have A intersection D plus B intersection D, what will be the total probability here?
Probability D.
Probability of D. Okay. So if I were to now ask you, what is the probability of B given D? Can somebody expand this for me? Probability of B given D using Bayes' theorem. Which letter goes down?
D.
D will go down. This letter must always go down. Then on top, we're going to intersect what?
B.
Intersection what?
Intersection D. D.
Excellent. So I don't want to talk so much, but use these same principles, after which I'll take you to the toughest exam question and you enjoy probability. So the key thing is just on Bayes' theorem. So we have what we call the prior probabilities. These are the original probabilities. They always add up to 1. So for instance, our probability of A is 0.4, and probability of B is 0.6. Are they adding up to 1? Yes.
Yes.
So they qualify to be in the prior probabilities. Then if we have what we call the conditional probability. Conditional, whenever we hear a slash, that is a conditional probability. So here, probability of D coming from A. Suppose this is 10%, 0.10. And probability of D coming from B is 4%, which is 0.04. We don't need to add the conditional probabilities. They never usually add up to 1. They never do that. It's only the prior probabilities. So when we apply this one times that one, what we get is the joint probability, which is also called the intersection. So can somebody tell me, if I multiply this one times that one, not the answer, what notation do I get? Probability of A times probability of D given A. What do I get? Probability of D intersection what? A. So which is 0.4 times 0.1 to get 0.04. How about here? If I multiply these two, B times probability of D given B, what do I get? D intersection what? B. 0.6 times what? 0.04 to get what? 0.024. This one is 0.04. Then here I can ask you now, if I add these two probability, D intersection A plus D intersection B, the total I get is called what? The common letter, the probability of what? D. So when I add up this, I get 0.064. This is the probability of a defective or a D. Then lastly, you calculate what is called a posterior probability or a revised probability. So You need to understand the opposite of this one. What is probability of A given D? Can somebody expand that for me? Probability of A given D, what does it give us? What letter goes down?
Probability of D.
Then on top, what we have?
Probability of A intersection D.
Correct. So how do we find probability of A given D? Do we have A intersection D? Yes, the same as D intersection A. So 0 point what? 0.04. Over the probability of D we've just found here, 0.064. So we get 0.625. That is here. In short, when I divide D intersection A over D, it is simply A intersection D. I repeat, if I divide A intersection D over D, it's just a conditional probability. I know maturers don't want to think too much. Let's maintain this D down. It will be what? The D will just come down there. Then here I'll just put A. Suppose I had A intersection D divided by what? A. Let's maintain the same pattern. Which letter comes down? A. Then on top, I'm going to have a D. All right? So help me. X intersection Y over probability of Y. What do I get?
X probability X.
X given what? Y, right?
Yes.
All right, so I've talked about a lot of things just here. So if I divide D intersection A over D, I'll have A intersection A given D. If I divide D intersection B over D, this will be called what? B given D. So if I'm dividing 0.024 over 0.065, 0.064, I'm going to get 0.375. The revised probabilities also add up to 1, just like the prior probabilities. All right. Now, how do you appreciate this? I want you to appreciate this from the previous test questions that they wrote your colleagues. So I'm going to take you and guide you through what I've just explained in terms of the table. This is the easiest way you would understand probability. In a certain town, there are males and females. So 50% of the population. So the population probability of a male is what? 0.5. About a female? 0.5. Then it is known that 20% of the males and 5% of the females are unemployed. So that is conditional probability. This is called the prior, which is adding up to 1. Okay. So conditional probability, this would be what? Unemployed coming from the male is what percent? 20%, which is 0.2. Unemployed coming from the female is what? 5%, which is 0. What? 0.5. Correct? We don't need the total here. Here the total is 1. Then we go to the joint probability, which is the intersection. If I multiply these two, my notation will be what? Unemployed intersection male. Here, unemployed intersection what? Female. Even without getting the answer, I want us to appreciate the principle that when I add this joint, the common letter here is the probability of what? Unemployed. Because they'll ask you what is maybe the proportion of unemployed. So multiply this one times that one, I get 0.01. Multiply this one and that one, I get 0.what? 0.025. When I add this one, I get 0.0125. This is the probability of what? The unemployed total. So a question would come, what is the probability that of the total population they are unemployed? So this is about 1.2%. Then we go to the revised probabilities. So here the revised is simply the opposite of what the conditional. So this is simply probability of what? Let me just continue here. M given U, which will be the probability of M intersection U over the probability of what? U. So simply this guy divided by that guy, I'll get M given U. So 0.01 over 0.
Sorry to disturb you. How did you get probability of unemployed intersection, Mel?
When I multiply this one times that one, I get
When you multiply with what?
when I
0.5 times 0.2. I'm getting 0.1.
Oh, it's 0.1, yeah. Okay, just maybe a calculation error. So since people don't answer when I'm asking the calculations, so help me get the actual figures. So when you multiply this one and that one is 0.1, then when you multiply this one and that one, you get 0.025. And I add this one, I get 0.125. I think this looks more like it. Confirm?
Correct.
All right, then in this stead, how do we get the probability of what? M given U? It's 0.1 over 0.125. What are you getting?
0.8.
0.8, correct. 0.8. So who wants to help me find the posterior here? How do we find probability of female given they're unemployed? Can somebody expand for us first?
So probability U down there.
Down, we put the U. X. Don't make a mistake. Then on top.
Then on top, if female intersection unemployed.
Yes. So when you divide that, what are you going to get? Since they're adding up to 1, obviously, it is 0. What? 0.2. So this was in a test carrying 12 marks. Calculate the probability that a person is selected. Suppose the probability was found to be unemployed. What's the probability that the person who was selected was a male? Found 0.8. How many marks? 6 marks. If the probability of the person was unemployed, what's the probability that the person was a female? 0.2. How many marks? 6 marks. You get your 12 marks there. Right, people perished because of what? Lack of knowledge.
Lack of
Let's also dissect this one here. There are 3 machines, X, Y, and Z. These ones have the equal capacity. So we have probability of X, probability of what? Y, and probability of what? Z. So sometimes you're not given probability, they just say they have equal capacity. So meaning you just say 1/3 because it has to add up to 1. If there are 4, a quarter, a quarter, a quarter. So the total here is 1. Do we agree on that? So this is the prior probability. They didn't give us the probabilities of these ones, but they are just what? Giving us the same rate. They have equal rate. Then they'll tell you that it is known that the percentages of defective items produced by machine X, Y, and Z is as follows. So you should also know that the conditional probabilities never add up to 1. So conditional probability of defective. So you need to know how to write the notation. Defective coming from X, because this one must be down here. Is what percentage? 2%, which is 0.02. Who will give me the defective coming from Y? It's 7%.
So
Probability of D over Y.
Yes. About defective coming from Z? 12%. What's the next column that we're having?
that's
The
condition.
joint probability.
Joint.
So when I multiply this one in that one, what am I going to get? D intersection what? X. How about this one? D intersection what? Y.
Oh, why?
How about this one? D intersection what?
D.
Z. If I total them up, the common denominator is what?
D.
D. So they'll ask us what is the probability of the defective. All right. So let's multiply this one times that one. What do we get? 1/3 of 0.02, 1/3 of 0.07, 1/3 of 0.12. So we have 0.0067. This is 0.0233. This is 0.04.
That's called laptop, young.
So when you total up here, we're going to get 0. What? 0.07. Now, the examiner was very clear here. What is the probability that if from the bin it was found to be defective, the probability came from Y? So which part are they looking for? Just this part. They usually ask for one part. Me, I'm just complicating it because I want you to know everything. They just want the posterior for this one here. So it's the opposite. They're asking us to find probability of Y given D. Can somebody expand for us? Y given D? Okay, so put the D down there. The D is very
We'll go to the bottom,
Then here,
and then we're going to have probability of Y intersection D.
which we have as 0.0233. The probability of D is 0.07. Okay. 0.0233 divided by 0.07. What do we get? 0.332. 0.333. Preferably, don't overround off in probability because you may end up adulterating the final answer. So, let me take you to the example from class. According to the American chapter of the American Lung Association, 7.0, is it 70 or 7.0% of the population has lung disease. 90% are smokers. Of those having lung disease, 25.3% are smokers. Determine the probability that a selected smoker has a lung disease. All right. So now this is where people get the confusion from. Because when a question comes like that, they become confused. So what have we been given in the question there? We've been given information. Let me just use the same slide so that I expand it in my way. Okay. So according to the chapter of American Association, 7% of the population has what? Has a lung disease. So what are we given here? Probability of lung, we can use a key. Let event L1 be no lung disease, L2 be they have a lung disease. Okay, so those that have lung disease is 0.07. So 0.07 let me use my own letters. Okay, so say lung disease 7%, so 0.07. How about the probability that a person has no lung disease? Should be what? 93%. Okay. So we're also told that 90% are smokers. So smokers are 90%, 0.9. So probability that is not a smoker, a non-smoker, would be 30%. Or 10%, sorry. So we're told that determine the probability that randomly selected smoker has a lung disease. So this is a very easy question that requires you to think and digest what is happening. So you need to take note of words like if, of, given that, because this is where you're able to know you have conditional probability. So using our selection, so we can say suppose the person is selected random, let the sample space S be a smoker, L1 be the person who has no lung disease, and L2 be the person who has a lung disease. So note that L1 and L2 are complementary, which means that if one, they should add up one. Okay, in short. So we have probability of a lung disease 7%, which is 0.07. So probability that this person who has a lung disease is a smoker, what is 90%. So this is a condition. So lung disease, a smoker who's coming from the person who has a lung disease is 90%. So meaning the person who has no lung disease, therefore, will be what? 93%. And we're also told that the probability that 25.3% of people who are not having lung diseases are smokers is 25.3%. So simply, this means that a smoker who has no lung disease is 25.3%. So using our table to simplify issues, our prior probabilities. Okay. So we said Lung disease, what's the percentage? 7%, which is 0.07. No lung disease, the remainder,
0.9.
0.93. The total is adding up to what? 1. Then we go to the conditional probability. Conditional probability, smoker coming from what? The lung disease. Okay. The smoker who has the lung disease. We also have a smoker who has no lung disease. L2, L1 there. What data were we given? Who is a smoker with a lung disease? 90%. All right, and a smoker with no lung disease, 25.3%. Okay, smoker with lung disease, 90%. Smoker with no lung disease, and 5.3%. And I said conditional probabilities do not always add up to what? Add up to 1. So we don't need this total here. It's not always adding up to 1. At this point, are we together?
Yes.
So what's our next column?
Joint.
The joint. Good. The joint is also called what? Intersection. So we're going to multiply this one times that one. What are we going to get if we multiply these two? A smoker and he has a lung disease. Then we multiply these two, we're going to get a what? A smoker and has what? No lung disease. The total, if we add them, we're going to get the probability of a what? The common letter, which is S, a smoker. So let's multiply this one times that one. What are we getting?
0.063.
0.063. And when we apply these two, what are we getting?
0.235.
0.235. When I add them, what are we getting?
0.298. I don't know how this one is rounded off. Is it to 2 or 3?
0.298. Don't overround off, just leave it as it is. And what is our next column?
Okay.
The posterior or the revised. So this one will be the opposite of this. A smoker, lung disease coming from the smoker. This one, no lung disease, but a smoker. So we're simply dividing this answer divided by that in short. So let's get the values. What is this one? Divided by that. This one divided by that. So let's divide this into that and this into that. What are we getting? Zero 0.298 into 0.063. What are we getting? That's fine. 0.928 into this one here. Quickly.
Sorry, I was failing to unmute. It's 0.211.
0.211. Then this one down.
0.78889.
So what is this question? This is a person who's what? This is a person who is randomly selected, is a smoker and has a lung disease. And this is a person who's randomly selected, is a smoker and he has no lung disease. So they'll ask you any one of these ones. So let's go to our question. What's the question asking for? Our question, you can go back and see what is being asked for. Then we compare. So they're asking us to find the probability that a randomly selected is a smoker and has a lung disease. Are we getting the same figures? 0.211. So this question was asking for us to find the probability that a randomly selected smoker has a lung disease. So you can do this way. I'm sure most people get confused. Or you can just use this table, which is called the probability table, which will give you this solution here. Doesn't this look great and easier?
Much easier.
Yeah.
But again, my only question is, if I presented the table in the exam and I got the answer,
This one,
would he have a problem with
yes.
it?
No. This one is okay. It's an acceptable. In fact, he'll teach you how to use this table as well. This one is okay. Any other questions? Okay, did he go any further than this or he just ended on this question?
He's gone further because I think an hour ago he was on this question, so he should have gone further.
All right, so we look at the random variables, then we end on the random variables. But I have a class with you at 10. Or maybe do we do it online or we can do physical classes? I don't know. So discrete random variables is the easiest. I must confess. So when dealing with discrete random variables, we just want to know how to calculate the mean, which is summation of x times the probability of x. And we also want to find the variance, which is summation of x times the probability of x minus the mean squared, and the standard deviation, simply the square root of the variance. That's all. All right, so you'll be given values of x and their respective probabilities, maybe 3, 6, and 9. And the probability, for instance, you could have 0.2, 0.5, and 0.3. So find the 3, the mean, the standard deviation. So firstly, I'll use the table to help you illustrate and make your life easier as well. So just square the values of x first of all. Here you get what? 9. Here you get what? 36. And here you get what? 81. Then let's get there. I can call this column 1, column 2, column 3, column 4, column 5. So this x times the probability of x is simply multiplying column 2 times column 3. The total is simply the mean, as easy as that. So 3 times 0.2 is 0.6. 6 times 0.5, 3.0. 9 times 0.3, 2.7. When you add up this here, that is 13 carry 1 to 6.3. So this is what we call the mean, or summation of x px. That's what our mean. As easy as that. So mean is when you sum up values of x times their respective probabilities. So we have two types of random variables. We have what we call discrete random variables and continuous random variables. So discrete are whole numbers. Random, we can have 1 over 2, 2 over 3, 3 as fractions or decimals. So this is discrete random variables. So how did we get this 6.3? We simply multiplied 3 times 0.2 plus 6 times 0.5 plus 9 times 0.3. The total is simply 6.3. This is 3 marks. Can you fail to remember this surely? Then column 5 is simply multiply column 1 times the probability, which is column 3. So after we squared, we found this by squaring these figures. You multiply it by the probability. Here we get 1.8. 36 times 0.5, we get 18. It's 0. 0.3 times 81, get 24.3. So when we add these up, what we get? 11 carry 1, 18 carry 1, 43.1. All right. So the variance is simply a summation of x squared px minus the mean squared. So the answer we got here is 43.1 minus the mean we found, which is 6.3 squared.
Sorry, it's 44.1.
44.1.
44.1, yes.
Thank you so much. 44.1. So what is 6.3? Don't have a calculator here. I'm just using my head. Help me. 6.3 squared will be about 39.69, somewhere there. Okay. When we subtract this one, for 4.1, we're going to get 4.41. So this is called our variance. And our standard deviation is simply square root of 4.41. What is the square root of 4.41?
2.1.
I didn't hear that.
2.1.
2.1. Okay. So, are you enjoying discrete random variables? This is as much as it can go. It doesn't get any more complicated than this. All right. 2.1. The other complicated things would be maybe find the probability that x is more than 6. Probability of x.
So the x squared and the x will multiply the probability of x.
Pardon?
I'm saying it's just the x squared and the C1 and the C2 just multiply the C3.
For the mean, let me just go through it again. For the mean, just multiply C2 and C3 in the total. This times that, we get that. This times that, we get that. This times that, we get that. The total mean. That's all.
So I mean, okay.
Then to get the variance, we square face our x. So 3 squared 9, 6 squared 36, 9 squared 81. Then you multiply this one times probability. This one times that one is 1.8. 36 times 0.5, 18. 81 times 0.3, 24.3. When you total up, this is not the variance, no. Summation of what? X squared times probability of x. So this one, you subtract the square of the mean. So 44.1 minus 6.3 squared, that is where we get the mean, which is what? 4.41. And in square root 4.41, we get 2.1, which is our standard deviation. Now, Papa, our formulas and statistics, don't use these formulas. You can't, even some formulas will refuse for you. I don't know why people want to cling on. It's at this point where you don't use these formulas. Huh? Don't use these formulas. The mean is equal to summation of x. I see this a lot. Don't use this at this point. This is under random variables. All right. So if I were to just go to our slides, I said, what is a random variable? It is an outcome that takes a numerical value as a result of an experiment. So questions in his papers will combine both the theoretical part and the calculations. So don't lose marks on these ones. There are two types of random variables. I mentioned them. There's what we call the continuous random variables, which are on a continuous scale, like weight, temperature. They have decimal points. And we have discrete random variables, which include descriptive, quantitative data, like the number of people that are in this class. You can say they're 3.5, they're discrete countable values. Then this question, he likes repeating it. Maybe this year he may bring the other question. So can somebody help me? Let's do this question together. How do we find the mean? How do you find the mean?
The mean is summation of x times probability of x.
Yes, so just multiply this one times that one.
Like,
This one times that one. So this is the formula I was saying. If you're not using my table, he uses this to explain to you. It's the same thing. So 1 times 0.12 plus 2 times 0.15 plus 3 times 0.8 until the end, we're going to get 3.7. Are we together at that point? Are we together?
yes.
Please, if
Yes.
there's anyone behind, just raise your hand so that I explain to you. Yes, you can ask.
We are together.
All right. Then we go to how to find the variance. There are two ways. Number one, after finding the mean, you subtract the mean from each of the values of x. So 1 minus 3.7, we get that one. Then you square the answer, we get 7.29. Then multiply by the probability of x, which is 0.12. We get this figure here. This is what he'll teach you in class. What I taught you is a different way. I repeat, after finding the mean, subtract it from each of the values of x. So 1 minus a mean, negative 2.7. You square the 2.7, 7.29. Then you multiply this by the probability, we get 0.78. So 2, we subtract it minus 0.37, 1.7, square it, and multiply the probability, we get 0.4335. Until the last figure, 6 minus 0.3, we get 2.3. We square it and multiply by the probability of 0.14, we get this figure. The total value here directly is your variance. So this variance, when you square root it, we get our standard deviation, which is 1.61. I don't know, you choose whatever is easier for you to understand. So this is how we calculate the random variable. All right. I also taught you on the shortcut, you square this. So this is a shortcut method as well. When you square this, we have that. So we multiply this one times that, we get this one times that, we get this. So when you get this figure here, we subtract the mean, 16.28 minus 3.7 squared. We subtract it, we get 2.59. What I taught you, I don't know which one you like, but it's the same thing. Then the square root of that one is still the standard deviation. This is how we go about it. School FYI math sanka. So this is how to go about the conditional probability, how to go about the discrete random variables. All right. Are there any questions at this point? Please ask now or forever hold your peace.
I think this one is simple and fast but the other one is too long
The other one is,
and time consuming.
yeah, that's
I think it would easier make a mistake to find the because you're first subtracting. Okay, I don't even understand the second.
okay. Let's look at the previous exam paper. Let's see if there's anything that we can this is the 2022 paper they wrote. This is the 2022 paper. Okay, this is the exact question which came, we've seen. Calculate the mean of the data sets to calculate the standard deviation. So questions come from the QM Bible. I think I've shared it on the paid up group. Please answer all the questions if possible, if you want to make the making key. So this was about 6 marks. Then we are from doing this one. In a certain town, males and females are 50% of the population. 20% are males, 5% are females. What's the probability that it was a male? Probability that it was a female, except he reduced the marks here. Therefore, we did this. You remember this, huh? It's a walkover. So I think let me end here. I'll reserve the energy for binomial distribution and normal distribution, then we are done with probability. So I'll share the video. I will expect you to try. So question 3 probability came in 3 questions. That's why I'm emphasizing that you learn probability. It's your exam will be pregnant with probability. So this one is a very easy question. We did something similar last night. So maybe question 3, A and B could be your homework. All right. Question 3, A and B, unless you want me to do it with you. Is that clear?
We can try it
We try it, good.
as homework.
As homework, yeah.